The conflict between Isaac Newton and Gottfried Wilhelm Leibniz over the development of calculus is one of the most famous disputes in the history of science. This controversy, often referred to as the calculus priority dispute, revolved around who first invented calculus and involved significant personal and professional rivalry. Background of the conflict: independent development. Both Newton and Leibniz developed their versions of calculus independently in the late 17th century. Newton's work on calculus, which he referred to as the method of fluxions, began in the mid-1660s. Leibniz's development of calculus, which he called differential and integral calculus, started in the late 1670s. Publication: Leibniz published his first paper on calculus in 1684, introducing much of the notation still used today, such as the integral sign and the differential d. Newton's work on calculus was not published in a comprehensive form until later, although he had shared some of his findings in correspondence and through the publication of Principia Mathematica in 1687, where calculus concepts were applied to physics. Escalation of the dispute: initial accusations. In the late 17th century, accusations began to surface that Leibniz had plagiarized Newton's work on calculus. Some of Newton's supporters, particularly within the Royal Society of London, claimed that Leibniz had access to Newton's unpublished manuscripts and used them to develop his own calculus. Leibniz, on the other hand, maintained that he had developed his methods independently and was unaware of Newton's work at the time of his own discoveries, publications, and pamphlets. The dispute became more public and bitter in the early 18th century. In 1704, Newton published a tract called Quadrature of Curves, in which he outlined his method of fluxions. The Royal Society, influenced by Newton, formed a committee to investigate the matter. The committee's report, Commercium Epistolicum 1712, concluded that Newton had priority in the invention of calculus. It is worth noting that Newton had significant influence over the committee and the drafting of the report. Leibniz's response. Leibniz defended himself in various writings and argued for his independent discovery. He emphasized the differences in notation and approach between his calculus and Newton's fluxions. The debate also involved various supporters on both sides, who published pamphlets and articles defending their respective claims. Aftermath and impact: division in the mathematical community. The controversy polarized the mathematical community. In Britain, mathematicians largely supported Newton and used his notation and methods, while those on the European continent supported Leibniz and adopted his superior notation. This division led to a temporary stagnation in British mathematics, as the rest of Europe advanced using Leibniz's more versatile notation and methods. Resolution and legacy. The dispute continued long after both Newton and Leibniz had died. Newton in 1727 and Leibniz in 1716. It wasn't until the 19th century, with the work of mathematicians like Augustin-Louis, Cauchy, and Karl Weierstrass, that a more rigorous foundation for calculus was established, helping to move past the controversy. Modern historians recognize that both Newton and Leibniz made significant and independent contributions to the development of calculus. Their combined work laid the foundation for much of modern mathematics and science. Conclusion: the Newton-Leibniz conflict over the invention of calculus is a testament to the competitive and often contentious nature of scientific discovery. Despite the bitterness of their rivalry, the contributions of both mathematicians were crucial to the advancement of mathematics. Today, their work is seen as complementary, and their combined legacy has had a profound impact on the development of mathematics and its applications in various fields.